Hi everyone. I apologise. I'm recycling this talk. This is based on a paper that I was in the proceedings of A-Life 2023, and it's a cut down version of the slides that I gave to present that paper. So I hope that's okay. So the main claims that I'm going to give in this presentation are firstly, that we falsely take software systems to be physically unreal because they're intangible. I'm going to claim that this may be because of features to do with our own embodiment and the cognitive biases this induces. And I'm going to recap some core principles of embodied cognitive science. And I'm going to, well, in the paper, I consider 8, and I argue that almost all, if not all of them, do not support the idea that these fundamental principles of embodied cognitive science are only applicable to tangibly embodied systems. Okay, so I'm not making the claim that ChatGPT is an agent in this talk. I might make it in some other talk, maybe, I don't know. But in this talk, the claim that I want to make is that we shouldn't suppose that it cannot be an embodied agent simply because it is a software system. And when I say embodied agent here, so I'm a scientist, I mean embodied in senses that are relevant to the scientific study of cognition. I'm not saying that ChatGPT is an agent or isn't an agent. I'm just saying, and I'm happy to say that it's not a tangibly embodied agent, but I want to say that's not scientifically relevant. Okay, so I asked ChatGPT whether it was embodied, and it said, there were highlights in the original slides, it is not embodied in the sense that it does not have a physical body or senses. It does not have the ability to perceive the world or interact with it in a physical way, and it's purely a digital entity that exists within a computer system. If anybody's familiar with the notion of digital dualism, I think there's some significant resonances here. Also, I think this goes flatly against physicalism in sciences, right? It basically says that ChatGPT works by magic. Because if it were not entirely, 100% unambiguously physical, we would not be able to interact with it at all. And we know that it doesn't work by magic because it was built by muggles. Okay. So this is a little bit of a kind of just a like a conjecture. I'm not making any kind of hard scientific claim here, but it's worth noticing, in English at least, we use concepts related to tangibility and hardness and weight and solidity as metaphors for something being undeniably real. We say tension was palpable. We took concrete steps. There were tangible benefits, solid evidence, firm conviction, hard facts. And as far as I can make out, this is not unique to English, right? This is reasonably common across a variety of human languages. And my conjecture is it's because of our own particular embodiment. The way that we interact with the world is through things that we can touch, and we have kinesthetic and tactile modalities, and that we use those metaphors to structure our thinking about more abstract domains. The problem is physics does not privilege tangible phenomena, right? Streams of neutrinos that just pass straight through the Earth, you certainly can't feel them. Physics treats them as unambiguously physical and real as rocks that we can pick up and hold in our hands. Software is just as physical a phenomenon as hardware. Otherwise, it would have to work by magic, which we know it doesn't. And my claim is that biology doesn't privilege tangible phenomena either. So olfactory and visual modalities don't involve kind of touching things in a way that transmits forces in a kind of a largely coherent array, but they're just as important to biology. And things like the electrical properties of myelin sheaths around nerves, right, they're just as biologically real and important as like mechanical properties of knee joints. Okay. So I mentioned cognitive science and embodied cognitive science, and there's quite a lot of literature about it. There's an influential paper back in 2002 that describes 6 principles of embodied cognitive science. In the paper, I consider all 6 of them and 2 more for good measure, and I argue that the lessons of embodied cognitive science do not presuppose a tangible embodiment. So what are these views of cognition? So there's this, like, cognition is situated, that is to say that it involves interaction with its environment in a kind of ongoing and significant way. Cognition is time pressured. We offload cognitive work into the environment. The environment is part of the cognitive system. Cognition is for action. Offline cognition is body-based. So, I mean, again, like, I don't have time here to go through all of these. I'll pick a couple of examples. But in the paper, I claim that most, possibly all of these, apply equally to software systems as they do to robots. So in particular, consider we offload cognitive work onto the environment. So we make the environment hold or even manipulate information for us, and we harvest that information only on a need-to-know basis. Those interactions which offload information into the environment, they do not have to be by pushing on things, right? They can be by swapping electrons along a wire or whatever it might be. Or Wilson's principle that the environment is part of the cognitive system. The information flow between mind and world is so dense and continuous that for scientists studying the nature of cognitive activity, the mind alone is not a meaningful unit of analysis. Well, again, right, Wilson's there talking about information. Information theory as a branch of mathematics is substrate independent, does not require that information processing be done in by throwing rocks at things. And in fact, it isn't in digital information processing hardware. So it doesn't seem to me that this core principle of embodied cognitive science presupposes that the physical interactions between the system and the world be those between, like, roughly speaking, a kind of a coherent blob of matter and stuff that pushes on it. Okay. Why is any of this important? Well, one reason is that we should be doing science in science and not just depending on our pre-scientific intuitions about what makes bodies and what sorts of things are undeniably real. Because those, apart from anything else, we know that those are biased by our own embodiment in ways that aren't consistent with the rest of the physical sciences. Secondly, I think, because if we don't treat these systems as being embodied systems, we invite kind of traditional cognitivist analyses of how they're going to behave and what their abilities are going to be, and what the consequences of their behavior are going to be. We'll leave these questions in the hands of theorists who think that the system alone is a meaningful unit, right? Or who think that cognition is not time pressured, or who think that effective behavior requires accurate and detailed internal representation, right? All of these things, I think, I'm going to just say as a 4E cognitive science, we now know that these are just plain wrong. And that's emphasized by traditions in embodied cognitive science. And we need to be bringing these insights to the analysis of the behavior of software systems, just as much as robots. Okay, so in summary, right, sorry, we've had some formatting issues. So the idea that undeniable reality is tangible, that is just a metaphor. It's not a scientific principle. It goes against more scientific ways of thinking about these systems. If a chatbot could not acquire relevant information about the world state or interact with the world in a physical way, it just would not work at all. And then secondly, I want to emphasize this point that many important principles from embodied cognitive science need to be applied to, if we ever do get things that we want to think of as agents that are just purely digital, right? we need to apply the lessons of embodied cognitive science as much to them as we do to robots. Okay, thank you very much.